Hello everyone! Today I'm going to explain a formula that you can use when you can't have two items next to each other. So I'm going to share my screen. So here's the first problem. Hopefully you can see the screen. So let me just So if Libby, Lee, Kesha, Brian, Megan, and Colin are standing in a line, and Libby and Lee have to stand next to each other, and Kesha and Brian have to stand next to each other, and Colin and Megan cannot stand next to each other. So how many ways can they stand in line? Okay, so let's get their names. So we have Libby, Lee, Kesha, Brian, Megan, Colin. Okay, so the problem says that Libby and Lee have to stand next to each other. So I'm just going to circle their names right like this. And the same goes for Kesha and Brian. They have to be standing next to each other. But Megan and Colin cannot stand next to each other. So cannot. I'm just going to put a big X. Circle these two individually because they can't stand next to each other. So the problem asks, how many ways can they stand in line? So when there's a scenario where two people cannot stand next to each other, we can use this really helpful formula. The formula is, I'll just put it in a box right here. N factorial minus 2 times n minus 1 factorial. This formula will help us find out the number of ways we can arrange these people without Megan and Colin standing next to each other. So first we need to find out what n is equal to. And n is usually the number of items. So you would assume it would be 6. But because Libby and Lee and Kesha and Brian have to stand next to each other, we can assume that they're both each a group. So we have one group here, another group here, and then Megan and Colin are individual. So n is actually 4 in this case. So let's plug it in. I'm just going to use another color. 4 factorial minus 2 times 4 minus 1 factorial. So let's solve this. 4 factorial, which is also the same thing as 4 times 3 times 2 times 1, is equal to 24. So 24 minus 2 times 3 factorial. And 3 factorial is also the same thing as 12. 12. You have to do 3 times 2 times 1, which is just 6. So 6 factorial, 6, not 6 factorial. So if we simplify that using PEMDAS, we get 24 minus 12, which is then equal to 12. So 12 is the number of ways we can arrange these 4 groups. But that's not the only thing we have to do, because since we've grouped Libby and Lee and Kesha and Brian, we assume that Libby will always be in the left position and Lee will always be in the right. Same goes for Kesha and Brian. But Lee could stand over here, so Lee could stand right here and Libby can stand right here, but they'd still be standing next to each other. So because of that, we have to take our results here, so 12, and we need to multiply that by 2 factorial for the number of combinations Libby and Lee can stand next to each other. And we need to multiply the number of combinations for Kesha and Brian, which is also 2 factorial. So 12 times 2 factorial times 2 factorial, which is also equal to 12 times 2 times 2, which is equal to 12 times 4, which is equal to 48. And this is the number of ways they can stand in line. So that's our first problem. I'm going to pull up a second problem that also uses the same formula right here. Okay, so here is our next problem. The figure shown is divided into 5 regions, A, B, C, and D. D and E. What is the number of paths that can be drawn that begin at any region, move only to adjacent regions, and visit all 5 regions exactly once? From the wording of this problem, it sounds pretty complicated because of all the information. First of all, they can be drawn that begin at any region. They can only move to adjacent regions, and they have to visit 5 regions exactly once. So, a way to get this organized, so let's just mark every region in a different color. So A will be red in this case, and I'm just doing this so we can visualize this easier, because there's a really easy way you can solve this problem. So you have D is blue, and E is purple. So A, so say you were on the A block. So I'm just going to use black. See, you start off at the A block. And there's many places you can go from this starting point. You can go to the B tile because it's adjacent. You can go to the C, D, or E. So let's just write that down. So you can go to B, C, D, and E. Now, for our B thing right here, so B, our B region, we can, so let's say we start right here. We can go up here, here, or here. So we can go to A, C, D, and E. We can go to every region other than B itself. So if we continue that pattern, so let's have C right here, right here. So we start at C right here. We can go to A right here, D here, and B right here. But we can't go to E right here because it's not adjacent. You would have to first go to D and then E, or you could go to A and then E too. There's many options. So in this case, we can only go to A, B, D. We cannot go to E. So now let's do the next one, after D. D can go right here, 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 and here. It can go to all the regions because they're all adjacent. A, B, C, E. Now our final region, which is the E region, can go here, 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 but it cannot go to C because it's not adjacent. So A, B, not C, D. So those are all the places, that you can go from starting on each of these tiles. So if you look closely, you can see that these 2 regions right here, these never touch each other. Like if you start at C, you can never go to E directly. You would have to go to another region before going to E. And same applies for E. You would have to go to B and then go to C. There's many ways. So if you think about it, it's also like our last problem where Colin and Megan, or whatever their names were, couldn't stand next to each other. So we can take these variables right here and take them as people, like our last one. So A, B, C, D, and E. But C and E cannot be next to each other. So our formula from last time was n factorial minus 2 times n minus 1 factorial. So let's plug it in right here. So we know that n is equal to 5 because there are 5 groups. There's no need to have 2 of them be right next to each other. 5. So 5 factorial minus 2 times 5 minus 1 factorial. And if we solve that, we get 5 factorial is also the same thing as 120 minus 2. And then 5 minus 1 is 4 factorial. And 4 factorial is also 4 times 3 times 2 times 1, which is 24. So I'll just put 24 right here. And because of PEMDAS, we multiply first. So 120 minus 48 is equal to, you can just do the math on the side, 11, 2. Our answer is 72. And that's how you would solve this problem. Instead of drawing every single path out by starting here, or then going here, etc., you can just use this formula right here. It's very handy to know. So I hope this video helped you understand about the formula when two things cannot be next to each other. Thank you for watching.